The last video really should have just been called part 1 of multiplying polynomials, or actually just what it said on the paper, multiplying polynomials by monomials. Now you'll see we have two sets of parentheses. In this case, we're just multiplying binomials. So inside each set of parentheses, there's just two parts. We can use a special little acronym to remember the order to multiply these in, or to not forget all the parts, and that is called FOIL. You might remember that from traditional school. Personally, I don't usually use the word FOIL much because it doesn't work once we have trinomials or bigger polynomials. And so I typically just think of it still as distributing, and I'm just going from left to right. It is the exact same order as what that says, so if that's helpful to you, use it. So x times x is x squared, then x times 4 is 4x. That guy's done multiplying. Notice he does not multiply within his own parentheses. He goes outside of his parentheses. And then now, the 2. Remember before I said rainbows? These are my smiley faces. So I got rainbows and smiley faces. Just wait for the unicorn, right? And then what you're going to see now, that we didn't have usually before, was a combined like term step. Typically those ones in the middle. Same process. The first times the first. The outside times the outside. Notice I'm still just going left to right. Then the inside times the inside, because now it's 1's turn. Or you could simply write x. And then last times last, the last one in each binomial. 1 times -5. The 2 in the middle are like terms. They can be combined. Alright, so I'm going to scroll down. I want you to pause the video and then check your answers with mine. Okay, so as I did these, after doing them for many years, and maybe for you, even just after doing a few, you might have noticed that for ones like these 4, you could take a bit of a shortcut. And if you didn't notice, I want you to think about what you observe about this number compared to those two. 8 plus 1 is 9. And this number is where we got from 8 times 1. Let's see, if I would add these two together, I get 1, and that's the same as that, right? If I add these two together, and if I add a positive 2 and a negative 2, I get nothing. So, yeah, there is no middle term on this one. This gives us something we call a difference, the difference of squares. The middle term is canceled out. Now, that little shortcut of being able to add to get the middle allows you, some of you may already be able to do that, you could just go straight to this in your head. You know it's going to be x squared, -10 plus -4 is -14, x, -10 times -4 is +40. We'll talk more about that pattern later, but it doesn't work for everything. Like there's not going to be a -4x in the middle on number 5. So don't try to overuse that observation, because here, when I distribute, it's 4x times 3, not just x times 3. So then when we combine, you can still do some things in your head, but it's not nearly as obvious now. So again, at here, 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 here. final answer. The negative 4n, the negative 5n add together to make negative 9n in the middle. Moving right along. Let's look at number 10. Number 10 is a little bit like our x plus 2, x minus 2. Notice that the two binomials are the same except the sign. So something interesting happens whenever that's the case. So I did my first times first to get 9w squared, negative 3w, positive 3w, and then last times last, negative 1. Notice what happens when I combine like terms. Those two guys in the middle, they're opposites, so they just cancel out. And what I'm left with is the difference of the square of this minus the square of 1, which is just 1. So if you see that they're exactly the same except the sign, there's a little bit of a shortcut you can use there. The middle terms will cancel out, and what you're left with is the difference of squares. Got another special case coming up that there's also a shortcut, but most people don't remember the shortcut and they leave something out. So let's take a look at that. Alright, with number 15, we have x plus 4 squared. So we need to remember what this means. What it means is x plus 4 times another x plus 4. So a lot of times I just tell my students, write it twice, or mark this out and write it a second time, and then treat it like any binomial times binomial. X times x, x times 4, 4 times x, and 4 times 4. And then the two in the middle will add together. But notice, if you thought, ooh, there's a shortcut, it's just x squared plus 16, you would be losing that entire middle part. So be careful. After I do a couple of these, then we'll talk again about what might the shortcut be. So this is my little shortcut, is just to take that off and rewrite it again so that I don't have to write so much. And then 2m times 2m, 2m times negative 5, negative, okay, now I've done these two, now I'm ready here. Negative 5 times 2m, same answer again, negative 5 times negative 5. Noticing something curious, that those middle terms for both of these problems have been the same. Okay, not opposites like when they canceled out, the exact same. So squared means it's written twice, and then I distribute p times p, p times negative 7, negative 7 times p, and negative 7 times negative 7. Combine those middle terms. Very interesting. So, again, this means this times itself. And you could just scratch out the 2 and go from there. A times a is a squared. When we multiply with two different letters, no matter which one is first, we're going to put them in alphabetical order. So a times 3b plus 3ab. And then 3b times a is also 3ab. We just go ahead and we can rearrange them. It's legal. And then 3b times 3b is 9b squared. two in the middle are once again the same in like terms. So this pattern is called a perfect square trinomial. And if you're not big on memorizing patterns, just remember you need to write it twice and do it the way you do the others. If you like patterns, you might notice this and find it kind of cool. Perfect square trinomial, if we just use this case of a plus b to the second, you square the first one, you square the last one, but it's at the end, and then there's a double combo in the middle. 2 times their product goes in the middle. So whatever a and b are, you multiply them together and you double it. I call that my double combo. Oftentimes people forget the double combo if they try to take a shortcut. So let's try one here out to the side, and I'm going to use the double combo method, or my little perfect square trinomial. So if I had 2x plus 5 squared, then I would go, 2x squared would be 4x to the second. In the middle, 2x times 5 is 10x, but I double it to get 20x, and then 5 squared is 25. So, it can be faster, but if faster means you're forgetting the 20x in the middle, it's not a good idea. Alright, so just a couple more examples. These are binomial times trinomial, which simply means that the problem is getting longer. And this is why I don't usually teach FOIL, because with FOIL, I don't have a way to label this. So I'm just going to distribute and go from left to right. So the x starts here, and then here, he's just got more places to go, and then here. Now, the one thing that's going to change a little bit, instead of making one big row of 6, I'm going to start a second row when I start multiplying by the 4. It's not just going to be any old row. I'm going to move it over so that things are lined up. So 4 times x squared is 4x squared. Notice how I indented that. And then 4 times 3x, and then 4 times negative 6. Why might I have done that? Because it puts my like terms together, and it makes it fit in my little box. So, x cubed, remember this last step, we're just combining like terms. Do not change those exponents. Now, if your original problem, the binomial or the trinomial, jumps around and it is not in nice second power, first power, constant form, then things might not line up. So you just have to pay attention. But the problems you're going to see in your homework, they do. They're going to work very much like this one worked. Alright, so try number 20. I'll work it out and put my answer down. So pause me, and then come back to check. You didn't pause me. Okay, you did? Alright. I hope you tried it on your own. So that whole thing of two different rows, very much we do different rows when we do multiplication with numbers by hand. Alright, hope this is helpful. This will be helpful for homework 8. If you have other questions, get in touch. Thanks.